You have learned about permutations. In this module, you will learn about various permutations with given conditions. First, let's see about permutations when repetition of the objects is allowed. The number of permutations of n distinct objects taken r at a time, where repetition of the objects is allowed, is equal to n power r. Suppose there are n distinct objects and r spaces. The first place can be filled using n objects in np1, that is, n ways. Since repetition of objects is allowed, we have n objects available to fill the second place. Therefore, the second place can be filled with n objects in np1, that is, n ways. Similarly, the rth place can also be filled in n ways. By the multiplication principle, the total number of permutations is equal to n multiplied by n, r times, which is equal to n power r. As an example, let's take 4 digits, 1, 2, 3, and 4. The number of 3-digit numbers that can be formed with these 4 digits, when the digits are allowed to be repeated, can be calculated as shown. Here, n is equal to the number of digits, which is 4. R is the number of places in the 3-digit number, which is equal to 3. This implies that the number of permutations possible with the 4 digits, taken 3 digits at a time, is equal to 4 power 3, or 64. Now, we will discuss about permutations when not all of the objects are distinct. Let's use a tiling example. We have a frame and 3 tiles, 1 blue and 2 yellow. We will see how many arrangements we can make with these tiles. For the sake of convenience, we mark the tiles B, Y1 and Y2. Now, the permutations available are as shown. There are 6 permutations. Now, if you remove the marks on the tiles, you will observe that 2 of the 6 possible arrangements coincide with each other. You will also observe that there are 3 similar-looking pairs. In the permutation, each arrangement repeats twice. Therefore, the number of permutations is equal to 3 factorial divided by 2 factorial. Here, 3 factorial relates to the total number of arrangements, while 2 factorial relates to the permutations within similar tiles. This is evident from the figures. Let's consider another example. Let us find the permutations of different words that can be formed with the letters of the word IIT. Let's mark the 2 I's as I1 and I2. The possible permutations are as shown. If we ignore the subscripts, the arrangements look like 3 words. Observe that every similar pairs of words are formed with 2 different permutations of the 2 I's in the word. Therefore, the number of permutations is equal to 3 factorial divided by 2 factorial. We can generalize this in the following manner. The number of permutations of n objects, where p objects are of the same kind and the rest are all different, is equal to n factorial divided by p factorial. In this example, the number of objects is equal to 3. The number of objects being repeated is 2. So far, we have seen permutations where only one type of an object is repeated. Let's now take a look at permutations where more than one objects are repeated. In the word banana, there are 6 letters. The letter A repeats thrice, while the letter N repeats twice. The number of permutations possible with the word banana is 6 factorial. Since the letter A repeats thrice, 6 of the possible permutations or 3 factorial permutations resemble each other. One such set of permutations is shown here. Therefore, there are 6 factorial divided by 3 factorial permutations. Coming to the letter N, we have 2 permutations or 2 factorial permutations that resemble each other. Therefore, we have the number of permutations as shown. This can be generalized into a formula. The number of permutations of n objects, where P1 objects are of one kind, P2 are of the second kind, Pk are of the kth kind, and the rest, if any, are of a different kind, is n factorial divided by the product of P1 factorial, P2 factorial, and so on up to Pk factorial. Using the theorem, we will find the number of possible permutations with the letters of the word trigonometry. In the word trigonometry, the letters T, R, and O each repeats twice. We will denote them with PT, PR, and PO respectively. The total number of letters is equal to 12. This implies n is equal to 12. Therefore, the number of permutations of the letters of the word trigonometry is as shown. Substituting the values, we get the number of permutations as 5,98,75,200. The specific case of the theorem is some objects in a given set of objects are of the same kind.